last section, as I mentioned. We're starting with Daniel Fagerberg, architect and engineer and sailor. Sailing a concrete boat.
Don't hate.
Yeah, you're going to have a presentation now regarding some projects you've done, of course. And then, as I mentioned before, save questions for the site visit. Then you're going to see some real-time
I'm going to make it quick.
Yeah.
Yeah.
Good.
So I want to thank you so much for inviting me here, Johan, to this stand in the shadows of the giants that has been here today. It's amazing work. This is the first time where I go to a conference that doesn't talk about why, that actually talks about how and how to measure this and how to go on. This is the first time. That feels just amazing and so inspiring. I also want to thank guys like the original gangster that I met here today, Søren Nygård. Here he is. Yeah, the pioneer. First time that I saw wood as a different material in wood fiber and Homaterm. Thank you for leading the way for all of us into biomass material, because it's not only timber. I also want to thank my brother, he's down there, Frederick, for being my patron during all this year, allowing me to continue with my homemade applied science that I've been doing. Thank you, brother, as always. He's also the CEO or head of ETC Bygg, which is the company that has built the high-rise where we're going later today. So, now we start. I'm actually Strömbro Building Workshop. That's my company. And I deal with this every morning when I wake up. And I'm so happy that I see so many depressed people here. Because this depression is the driving force to actually go up in the morning. And when I just finished my studies, I thought I was so depressed. This was the most awful thing. Everything is going to shit. So I delve into Ingmar Bergman and thinking he must be even more depressed than me. And then this comes up, the death and the knight who's fighting for his life. And then we have to start there and see what's happening. And now I have erased all the kind of why questions and everything like this, but I want to keep this one at least. And this is how we're building. This is something that is extremely important. And Guy, you just mentioned it, that our buildings makes us really, really sick. That's what it does. It kills 3 million people every year in the world. 3 million people die because we're actually building bad buildings. It's absolutely disgusting. So, anyway, I thought that every morning when I wake up, I'm really depressed, and then I say, well, that's my opportunity, that's my driving force, I call it fearability, and then I go to work and I'm going to solve this whole climate impact thing. And now, with all these guys' help, and with the help of the original gangster down there, we managed to get out materials that actually are biomass materials. So, what defines a carbon neutral material? What do we actually need? What is it, the common ground for it all? I would say that is the lowest degree of processing. If you can get as close to the source of the material as possible, that's the material that you should use. And that's what we do with this. Yes, straw, it's amazing insulating material. Granite, I know that we're talking about it, but granite is the original concrete, so to say. If we use the granite instead of it grinding it up and everything like into gravel, putting it as ballast, we can make beams, we can make foundations and so forth. Of course, we have the clay. The clay, this is an amazing fire. Got amazing fire properties, as Johan said. It becomes into tiles or porcelain as soon as you put fire on it. But then we also have the structural parts. And when we build tall buildings, when we're doing big spans, we are going to need to use CLT, for an instance. And then CLT becomes a problem because we don't have a sustainable forestry in Sweden. So this is the first step that we have to start dealing with. Linnéuniversitetet has got some fantastic researchers onto this, but now I even get depressed on the night because we see on the news that they're going to cut down the forest next to the mountains in Sweden. But together we will make new policies that will change this, and the European Union actually put in place regulations of how much clear cuts that you're allowed to make. So this is happening, this is going on. Second thing that hinders us from building or for changing the climate change is actually the cost control. If we can control the costs, we can actually build cheaper. Here is a really funny or weird kind of thing. The last 22 years it is here, or 20 years, it has become 25% more expensive to build. And nobody knows why. How is that even possible? When the projektering used to look like this, and today it looks like this, same productivity. When the things looked like this before, and it now looks like this. How is it possible that it can go 25% more expensive? Do you guys know? I still haven't figured out, but yes, someone said yes. Vinst, marginal. Well, that's not actually in part of this one. That's taken away from this equation. What I see and what we see on site is that there is when there's fewer people involved, there is not the same quality control that happens. People don't get too close into the details and so forth. You sit on computers, you zoom in, you zoom out, and you lose the bigger picture of everything. You don't get close to your materials as you used to do. So then I've always been interested in robots and everything like that, especially as you can play James Bond with it. If we then can bring the production of the material closer to what the computer generated, or the CAD or the BIM modeling is, if we can get closer to that, then the carpenter, who is actually the BIM modeler or the computer modeler, she becomes the carpenter in a way. So I started to develop software and stuff that could run those machines that should be as easy as playing Super Mario, and that worked fine. It just ended up in this code, which is great fun. And then we started to do Grasshopper and stuff like that, and started optimizing the materials, etc. And in the end, we could, after about 10 years, starting to design in super customized mass customization with natural material. This is a CLT tower in Stockholm. So, going from that, now we had worked with bringing up the idea of cost control through making digital twins and so forth, to looking at ourselves as the actual carpenters of this thing. And then we get these fantastic projects. I say this is Kaminsky Architects that does this. We were just the engineers of it. Just a couple of days ago, it actually won the the UIA, yeah, the UNFN prize. Fantastic to be part of that. This was the first project then in Västerås to build 2 self-sufficient energy-wise buildings that would charge your car, that was part of the carpool, that was financed by crowdfunding, and it has been the cheapest new built rental apartments in Sweden. So there are things still inside this building that wasn't really good enough. There was a little bit of waste and not real optimization of the material. We did end up using the gables. We're actually using CLT in the gables, which we could have changed mathematically. But anyway, this was as close as we got at that time. And one of the things with this is that, well, first of all, we do everything in SketchUp, so you get all of the really happy, clappy colors and everything. That it's fantastic. But here was our first real digital twin, where we had every screw, every dowel modeled in it. So then I'm going to show you in the end. When one material that we're using now, which is the EcoCon, we have to, as I say, we have to go as close to the source as possible, and we have to use the same material with all its properties as much as possible. So a material should be both insulating and load-bearing at least. If we can make it fire-safe, we can make thermal comfort with it, even better. So in lower scales, these kind of straw bale buildings or straw bale elements, they become load-bearing and hence also financially viable. But then when you comes to these buildings that we're building now, they can no longer be load-bearing. We actually have to create another structure for it. How does it then become financially viable? Then we go into and calculate the part of how long will this actually last. And what we see is that with the help of this material and a simple sheet on the outside, we don't have any plastics, we don't have any other materials inside it. We can easily access this material. So if we do get any problems with it, it's very easy for us to mend it. And that goes for everything. That goes for the wood, that goes for the clay, that goes for the straw and everything like that. So it's all about how will this work in the long run. And yeah, make fire tests and all these things. And there it is. And then we will go out and have a look at it. I'm sorry that I dragged on. I got this number one. 1 minute left.
So great, thank you.
Thank
and
you.
you will see this later, as I mentioned. So you will probably get a lot of questions when we're at the site, I believe. Okay, thank you. Next one.